All right, so we've talked about a little bit about linear functions, lines, and so now let's talk a little bit about what are called quadratic functions. We haven't talked a whole lot about degree of a function. Well, we haven't talked about it at all. But let me just phrase it this way. Quadratic function is a second degree function. And all that means is, second degree just means it's x squared. The power of the x, largest power of the x, is squared. That's all that means, second degree. So if it's third degree, largest power is 3. Fourth degree, largest power is 4. Linear functions, largest power is 1, so it's first degree. So that's all that degree means. So this just basically means that largest power of x is x squared. Different ways you can say it. Hopefully you know what I mean there. All right, now, so let's just talk about the easiest quadratic functions, the two easiest ones. F of x, first of all, f of x equals just x squared. Then we'll talk about adding some stuff to that, but f of x equals x squared. Very simple little function, and let's just do a simple little table here of different x values. Now, here's what I recommend on the ones we'll do. The x values, let's just do x values from -2 to +2, the integers. -2, -1, 0, 1, and 2. That gives a pretty good idea of what the function looks like. Now, the thing about it is, all right, so x is started with the hardest ones here. X is -2, all right, and so y, okay. Y, well, we're calling this function f of x. Y has been replaced by f of x, so y is just what f of x is, which is x squared. All right, that's how I get the y value. I just plug in the x. And so when x is -2, let's just do it right here. The y is just -2 squared. And when you square, of course, -2 times -2 is +4. Same thing for -1, -1 squared, -1 times -1 is +1. So it turns those into positives. And then, of course, the others are fairly easy. 0 squared is 0. This would be 1 squared, which is 1. And then 2 squared, which is 4. Is everybody okay with that? Everybody see where those came from? All right, now, so the graph here, if we graph those points, -2 and 4, here, -1, +1, 0, 0, and 1, 1, and 2, 4. Yeah, what we get is this little curved graph like this. Hopefully it's not hard to imagine. Yeah, this graph is going to continue on upwards in both ways there. 3, 9. The next one will be 3, 9. So yeah, it's just going to keep going up and up now. Okay? Yeah, so this is a pretty good example of what a quadratic function's graph looks like. F of x equals x squared. This is what, basically, all quadratic functions look like. It's called a parabola. One of the key components of a parabola is this. In this case, it's the lowest point It's called the vertex. And the vertex on quadratic functions is usually, if we don't know what it is, in general we just call it h comma k. The h is the x of the vertex, and the k is the y of the vertex, and that comes up later on, so that's why I'm telling you now. But here the vertex is just 0, 0. So that, and it's a lowest point. In that particular case. And there's one other thing I'll talk about here. After I do the second one I was going to show you, compare to that, fx equals negative x squared. All right. So if I do the negative 2, the positive 2 points, values on that, the thing is, this negative is outside the square, so I don't square that negative. However, when I plug in negative 2, I'm actually squaring that negative 2. The square of the negative 2 is 4, but I've also got that negative there. So I actually wind up with a negative 4 there. And then the same thing on the negative 1. You've got negative, and then you're squaring negative 1, which that squaring negative 1 is 1, but then you've got this negative, so it is a negative 1. So basically what happens is I've changed all the positives over here to negative. Of course, 0 still gives me 0. 0 squared is 0. And again, if I plug in the 1, 1 squared is 1, but then I negate that, so you get a negative 1 there too, and a negative 4 there. So yeah, I turned all the positives negatives. And so I've got negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4. What happened there? Yeah, it's flipped it over. And yeah, these are just going to continue down, those are going to continue down. Yeah, I've got a flipped over parabola. So it's still a parabola, but it's flipped over. Well, the way they phrase that is the way it opens up, or whether it opens up or down. This parabola opens down, and this parabola opens up. Up or down. So what was the difference between these two quadratic functions? Well, it was this right here, right? I had a negative x squared. Over here it was just positive x squared, or 1x squared, negative 1x squared. Yeah, that's the way, easy way to tell whether a parabola, quadratic function, graph, opens up or down. If the x squared term is positive, the parabola opens up. If the x squared term is negative, it opens down. And that will always be the case. Opening down, up. So it's a pretty quick little check there. Opens up or down. All right, now. There's another key ingredient, if you will. F of x equals 4x squared. 4x squared. All right? Parabola has got the x squared. Up or down? Parabola opens up, yeah. Because here is positive 4x squared. Okay? So it does open up. And again, as far as the graph goes, just do A couple of quick little points here. -2 to +2, so that would be plugging the x to be -2, so we have 4 times -2 squared. What's that going to give you? Well, again, -2 squared is 4. Then you multiply it by that 4, so you get 16. And then here you got 4 and -1 squared, right? X is -1, so that would be 4 times, again, +1, because you're squaring -1. 0, well, it's still 0, because it's still 4 times 0. It's still 0, didn't change that. That's 4. That's 16. So here's what basically happened. Got to have a few more marks on the y, right? The y, x is -2, but the y is 16. I think that's 16. So -2, I'm way up here at 16. At -1, I'm at 4. 0 is still 0. 1, I'm at 4. And 2, I'm at 16. This is my graph. That stuff. Right? Well, yeah, so opens up. Another point, though, we can make about this is, notice here, if I put in the y equals x squared graph, dotted in here, you know, 1, 1, 1, 2, 4, that's the x squared graph. Without the 4. What I can note there is that 4 right there made the graph narrower. So this number made the graph narrower. Okay, that's good. Good to know. All right, that's one other thing they'll ask you about on these. All right, let's notice this. F of x equals -1/3 x squared. F of x equals -1/3 x squared. All right, so again, x squared, parabola, but this one opens down, doesn't it? Because you got a negative x squared. The terms here for the table, well, you get maybe not so nice values, but they are what they are. Here, so it'd be -1/3 times -2 squared, so that's again -1/3 times the +4. Well, it's -4/3, -1.33 repeating. However you want to write that. Probably with the decimal, since we're going to graph this. Good that? Good there? This one, x is -1, you have -1/3 times -1 squared. So that's -1/3 times, again, +1. You're squaring -1. You get a +1, but it's -1/3 times that. So yeah, you get -0.33 repeating. 0 still gives you 0, but and then yeah, get about the same thing on these. 1 and 2. 1 and 2, you get the same as you for -1. That always happened, but didn't here. Okay. All right, so graph-wise then, here's what we see. -1, -2. Okay, so -2, I'm just at -1.33. Just a little bit below -1 there. And then at negative 1, I'm at negative 0.33, 0, 0, positive 1, negative 0.33, and then 2, I'm at negative 1.33 again. Well, that's what I get. Now, if I put in, let's put in just y equals, f of x equals negative x squared. Because that's negative 1, negative 2, 4, oops, positive 2, negative 4. Just for comparison here. How would you say wider or narrower there? Did this make it wider or narrower? It widened it out, didn't it? Here's just the x squared, negative x squared, so it's made it wider. Not only did it flip it over, made it go down, now it's made it wider. Well, what was the difference? This one made it narrower than original. This one made it wider than it was originally. What's the difference? Well, it's this number right here, right? This one's 4. This one's, technically what we're looking at there is just the 1/3 of that. The deal is whether or not this is bigger than 1. This is bigger than 1, so it made it narrower. If that number right there is bigger than 1, that makes it narrower. If this, and you kind of ignore the negative for this part, if that's between 0 and 1, it makes it wider. In other words, a fraction or a decimal between 0 and 1. Now, this brings up another point here. Let's call that number right there a. Ax squared. And that's pretty standard. I mean, probably seen it called that before, but call that number in front there ax squared. Well, what we saw as far as narrow and wider, if a, and let's call it the absolute value of a, just the positive part of the a. In other words, like here, I would be talking 1/3 instead of the negative 1/3. That's all that means, absolute value. If that part is greater than 1, the graph is wider. Narrower. So the greater than, yeah. It's narrower than f of x equals x squared. It's like the first one, where we had a is 4. That's greater than 1. So the graph was narrower. If that absolute value of a, just the positive part of the a, is less than 1, like this one, just the positive part there, that's less than 1. If that's less than 1, the graph is wider than f of x equals x squared. Okay? So it's just a couple of, took a lot of time, but a couple of quick little things that you can tell whether it opens up or down by that number, and you can tell whether it's wider or narrower than the original. Okay? All right.